Merhabalar herkese.
Hello, everyone. This is June 16, 2022. One day after the World Wind Day, we are together to discuss about the future of wind with regards to wind energy, not only wind turbines, but besides wind turbines, all associated technologies will be discussed and the future of renewables in the markets. That's what we'll be discussing. And to get detailed information on this, we have international professionals, experts under the online webinar organized under Turkish Wind Energy Association. And I hope that we actually will have a chance to get the information about each and every single detail. If you have any question in your mind, please do use the Q&A session of the Zoom, and I'm the moderator. I myself will try to answer to your questions, and also the speakers will directly answer your questions if any. Before we start the session, I will move to English, and I would like to introduce our topic and also our speakers, and then I will give the floor to each and every speaker.
So I'm just switching to English. So welcome again to all of our listeners and our participant speakers from various international companies and in Europe who are, expert professionals in their respective areas. So the reason why we are together is to discuss about the future of wind, not only turbines itself, but also all the integrated technologies that we are expecting to be integrated with wind, and also future market structures together with PPAs. I believe all these subjects are quite interesting for most of us, and I'm sure and I hope that we are going to have important insights and have a fruitful discussion about all these subjects. So just let me introduce our speakers shortly so that they can continue, of course, they can continue with the detailed introduction about themselves. But first we have Karolina from Simply Blue Group, Karolina Pietstak. Sorry for my pronunciation anyway. She's from Simply Blue Group, which is a developer and investor in offshore. And she's going to talk about offshore wind and technological and investment developments in that area. Then we have Till Jange from Nordex, Germany. He's going to talk about turbine technologies and future developments, expected developments in turbine technologies. He's the Vice President of Global Product Strategy and Sales Support Group at Nordex. Then Vasiliki Klonari, she's from Wind Europe and heading the Energy Systems Integration Department. And she's going to contribute about battery integration and energy storage applications in renewables, and how we are going to see energy storage affect renewables. Then Matthias Schlegel from Figner, he's the head of hydrogen, and as the name stands, he's going to talk about hydrogen and its integration with renewables. And then finally, Guy Brindley. We luckily met with him 1.5 months ago in Bilbao, and a short discussion about future energy markets and PPA. So he's going to talk about these subjects. Guy is working for Wind Europe, and he's the head of Market Intelligence Group. So after my short introduction, I will start with Karolina. So the floor is yours, Karolina, hopefully. We are going to have a smooth discussion. Thank you.
Thank you very much, Ibrahim. Hello, everyone here online. I'm Karolina Pietstak, Simply Blue Group, Deputy Chief Development Officer. Again, thank you very much for the invitation for this discussion. Great panelists today. And from my side, I had the chance to start this discussion. So that's gonna be a few slides which I presented or we will present to you and prepared to you. Let's start with that. And I hope we will then follow with some questions and some good discussions too. So I will now try to share my screen, and please let me know if you hear me well or hopefully there is no problem with that. And now I will try to share my screen. Just let me know if that's...
It's fine.
Yes?
If I see it, everybody most probably is seeing it, so thank you.
Very good, so quick check. Perfect, so let's start. So the offshore wind industry growth, that's the topic which I want to present to you at the very beginning, because yeah, the Wind Energy Association here from Turkey is talking about, and I think not only this association, Wind Europe, of course, bringing us as an expert in the different regions. So maybe a few words about me. So I've been working for the offshore wind industry since 2012. When I moved from Warsaw to Hamburg. I come originally from Poland, but I'm based in Hamburg, Germany. My background is power engineering, but I've been working from the very beginning for the different offshore wind companies. First of all, yeah, that was the consultancy, and then later for the developer. So the first 5 years, I've been very much focusing on the European market. When you recall probably the history of the offshore wind, where the feed-in tariffs, where there were like only few of the markets which were active in the offshore wind. And after this kind of important point in time, when the first German offshore wind auction happened, when the zero subsidy came, offshore wind, I'm saying always that offshore wind started to be not anymore only European thing, but the very international, very global thing. And after that day, I started to work on the US market, and the last 5 years I've been focusing there very much on the growth and working with the different developers on the portfolio, on the pipeline. And now at Simply Blue Group, coming back to my company now, I'm responsible for the international expansion. And I will give you a short overview about the company too, but mostly that what I want to present today is, of course, this project developer's perspective towards offshore wind. So let's start. So yeah, who we are. Simply Blue Group. So we are calling ourselves the Blue Economy Developer. Which means, and you are seeing here already, that we are like developing the floating offshore wind. We are focusing very much on this technology, on the wave energy, sustainable aquaculture, and some called deeper blue economy, which is hydrogen, CCS, and the other future technologies, which are very important and key for the growth. We are, and you can see a few dots on the map, we are having some presence already, not only in Europe, but in the United States. So the main, we call it like our headquarters is on the British Isles in Ireland. We have some offices in the UK too, as we're having our most advanced project, floating offshore wind projects there. So in the UK, we are working together with our partners on the 100 megawatt floating offshore wind project coming online by the mid of this decade. And similarly, in the US, we're working with the same partner, TotalEnergies, in Ireland with Shaw. And that's what I'm responsible now is, of course, is all different new markets which we are going to approach and be active on. So happy to be able to present, of course, the company and some perspective, our perspective towards offshore wind development. So maybe some, I think the key elements, not to take too much time, I think I prepared only this one slide about Simply Blue Group. Happy to discuss after the panel if you have more questions on that. But yeah, we are the team of 70 plus people. We will have our annual meeting in September, and I heard that's going to be around 90. So we are growing fast as the industry is growing very, very fast, and we are trying to make an impact, creating value from this early stage of development of the project towards financial investment decision, at least. So you see, we have already around 10 gigawatts in our early stage floating offshore wind projects under development. We raise some money for this purpose, of course. There's 10 countries where we are active around. We have very strong partnerships around the globe. And yes, and we are really looking into the expansion as said, my main focus for the time being. Okay, so a bit of perspective which I wanted to present to you today is, if you see here on the left-hand side, and you know that for sure, as we are on the wind panel already, and okay, somebody is not on mute, so but that's fine. So coming back to that, what I want to show you here is, of course, that we are working on the offshore wind already for some years, and as said at the beginning, that was very European thing. We built it up. The first fixed bottom project started already more than 10 years ago in the commercial scale, and now we are seeing, of course, like a big developments around the globe, as said, and we are seeing something else. So that's the fixed bottom areas are slowly not sufficient. So in order to let's say capture the potential, we have to go into the more deeper water where the floating technology is required. And looking into the map and looking on the right hand side on the graph, you can see that yeah, there is a huge potential, as said. The 20% is the fixed bottom technology potential. So and the 80%, so remaining part is floating. And my company, Simply Blue, is very much focused on this floating one. And I think important what I think here the questions are, of course, do we need to use it? Do we need to put this turbine into the water? That's something which we have to probably discuss or rediscuss, having exactly the situation which we are having in Europe. So the war in Europe happened, and that how it impacts that we see a lot of updates in the energy policies, in the energy targets, which means that I would call we will have an energy transition too. So the primary energy and the dependence on the fossil fuels has to change right now. So offshore wind is the large scale potential which is going to be utilized in order to meet the targets of this energy transition. So I think that there is no doubt that this potential is needed. And what is an offshore wind demand globally? That's something which I had been asked always when we are entering new markets in the different companies. And I think this demand is just growing as we are growing as a society, as that what is happening around the globe is changing. So I think this energy transition now, so the targets and the demand 5 years ago was different than that what we see right now with the new technologies upcoming. So the floating offshore wind, the hydrogen or the e-fuels are going to be a game changer towards utilization of the offshore wind potential. So let's go to the next slide. As said, I wanted to give you a bit of developer perspective. So you saw already some numbers. Of course, now many governments across the globe and the developers are assessing and selecting offshore wind sites for the offshore wind project development. And that what you saw earlier, it's just the technical potential. Of course, very big role of the different entities locally on us developers to consider so this local aspects and economical aspects as well. So in order to really define the real potential and know how much we can deploy the offshore wind in the particular markets, we have to do some work. So that's something which is under development right now. And as said, there are different structures on the different markets. So sometimes developers are seeking for the sites and deciding where they want to put their flags and working on. Sometimes the government is defining the sites in advance and selling in some different processes and concepts. And I think that the message which I wanted to give you here is that that what Simply Blue is doing, and we have our expertise. We are saying that it's paying off in the different markets. So the early stage engagement, so de-risking work on the project is really key in order to be able to create the successful coexistence in the ocean. Yes, and so now let's jump to the right hand side, and here we see how the predictions are for this decade. So of course there are more and more gigawatts which are coming on the pipeline, but that was one of the GWEC assumption by 2030 I put on the slide here, and we see that yeah, almost all continents are growing. Europe very much, China, of course, Asia itself, North America, as said, very big increase in the targets. And that's why, like, seeing these numbers, we have to keep in mind that's yeah, from 2021, seeing what is going on around the globe, plus changes in the policy can really jeopardize this number still. So let's see where we end up, but for sure we have to work all together, and I will talk about that on the next slide. And last but not least on this is that what I just wanted to mention with regards to this step from fixed bottom to floating. So it's a very natural step, as said. If we are going farther from shore, that's less constraints, mostly less constraints area, not big visual impact as you are farther from shore, of course. It's of course based on the technology which is starting to be implemented worldwide. So you see there is 100 megawatt around floating farms or structures in the water based on the old oil and gas technology, which is already known for years. But there are a huge pipelines which all the developers are working on. So for the deployment by 2030 and 2040.
Carolina, just to open up, what I
Yes.
see on the screen is annual installations, right?
Annual installation, yes, that's not summarized. Exactly, that's annual installation, new installations.
So I was, in fact, while looking at the final numbers for 2030, it was like 40 gigawatts doable. I mean, it's anyway very ambitious. But on average, we are talking about 20 gigawatts per year installation. Of course, it's going to grow and grow, but those are impressive numbers. I hope Turkish voters will also add to those numbers in the future.
Of course, and I think, yeah, that there is a big chance that if it's the Wind Europe or the GWEC or your organization is investigating exactly the sites, what I'm saying, like there are two different ways. There is a way so-called developer-led, so that developers are assessing the site, submitting the application, checking the site conditions, being interested and developing the project in this way, or the government is organizing the process and letting, like, organizing themselves, assessing, selecting the sites, and then organizing, of course, some competitive rounds to let developers get into the development itself. So I mean that's exactly the time to decide how to do it. There are, of course, pros and cons on each of the approach, but yeah, the time is now to talk about that and be part of the industry, because that's the most important. So if you want to, yeah, be part of this huge grow, you have to start now. Yeah.
Hopefully.
Good. So Okay, so here that's looks a bit messy, I think, but at the end it is the project development in the offshore wind is very complex. So we have a lot of aspects which we have to consider, and there are different phases. So we have the planning, development, execution phase. I just wanted to show you that these all aspects are key and are important to be set up, to be transparent, to be clear for the development, for the stakeholders. So in order really to have successful deployment of the project, there is, example, it's not only offshore wind park has to be there. You have to organize your transmission, of course, to let the green electrons to get to the grid. So if there are no clear targets, the market is, of course, not sure, and the commitments from the developers and supply chains cannot be so strong. So I think this all attributes, I think sometimes one missing attributes can really negatively impact the whole portfolio. And there are many examples like that in Europe to how the markets, because of exactly this no transparency and no clear pipeline and support, has been delayed. Now, as the energy transition has to kick off very fast, and we have no other option than deploying the big scale offshore wind, we have to work on that in this complex way, but in the cooperative too, because like and maybe that's something which I wanted to bring you here too. So there is a lesson learned from the different markets. So you don't need to, in Turkey, start offshore wind from scratch. So I think there is a lot of approaches how to communicate with developers, as my company is, or the others, of course, to take these lessons and coordinate and organize the process in the best way. And I'm not sure how much time I still have, but I have I think one more slide, which is I think the most important at the end, and especially from the floating offshore wind perspective. So I brought you here one example, which is from the US current, that was the supply chain assessment, which they did for their growth. So United States saying 30 gigawatts by 2030. What do we need from supply chain perspective for transmission? And you have some numbers, what has to be prepared. And of course, like it's the investment, is the local workforce, everything which can positively impact the economy and positively impact the growth of the country. So that's kind of the new industry you can enter. I know Turkey has already a huge experience with the onshore wind, so it's not so much new, not everything, but there are still many let's say many different branches which you have to maybe readjust. I had the chance already to be once in Turkey, visited great harbors, and saw that the shipping industry and business which is already there, having a lot of discussion about the floating offshore wind, and I see the fit for the industry you are having with the potential floating offshore wind structure which are going to be built in the whole Mediterranean region, as the Mediterranean is entirely floating. So that's why I think that the piece here on the supply chain is especially important for Turkey to be mentioned. But of course, it has to be, again, it has to be coordinated. It has to have a plan, the roadmap to attract the investors, to attract and enable let's say the growth of the portfolio, the growth of the industry in kind of the natural way. So that's maybe and I'm not sure if I have one more. No, but I will only.
That's the final one.
That's the one. Yeah, that's the final one.
Yeah, we have. So you're mentioning that offshore. Get the final words. Offshore brings significant cross-sectoral cooperation, not only turbine manufacturers and construction companies, but
exactly, and especially
it brings marine and maritime. Yeah,
exactly, and especially for the not for the all markets. We should be very, very clear that looking from the offshore wind floating perspective, as I'm looking very much into that right now, there are certain markets which are fitting to that. These markets which are having the shipbuilding expertise already, and Turkey is one of them. And as said, the floating offshore wind potential in your region is going to be huge. So of course, there is still fixed bottom to be done. And fixed bottom is something which already there are a lot of experienced EPC companies who are working on that for years. So I'm just showing you an kind of the perspective, which is still at the beginning of the path, but it's going to grow very fast. So yeah, in order to take this trajectory, you have to start and work on that now. So I think that would be my final message.
Thank you for the words and recommendations. In fact,
you're welcome.
This is what we are also after, to start offshore in Turkey anyway, because we are aware that, as you rightfully mentioned, offshore brings cross-sectoral cooperation, and those sectors are the ones mainly which Turkey has a competitive advantage. Shipbuilding, maritime, I mean, lots of alternatives, vessels, cable manufacturing. Those are industries that Turkey has some ground. So we can build upon that. And we shouldn't be waiting for the onshore to be completely finished and then start offshore. I believe a coexistence of onshore and offshore should be the right solution. Both for the industrial development and also for the energy supply issue. So the second, switching to the second speakers, and thanking to Caroline again. I'll give the word to Till. He's going to hopefully elaborate some about the situation of the onshore wind industry, because although we see a significant interest towards wind investments and solar investments globally, investments cannot just start like with one click. I mean, okay, we need wind because there is a significant time required for the development, and there are ambitious targets being announced by Europe, by US, and other countries, but those would turn to investments most probably in 2-3 years time frame. My first question to you is, how do you see the situation in onshore wind industry based on these future expectations? And then I hope you can follow with the question of everybody's, question. Are these turbines going to be? I mean, are we going to see 30 megawatt turbines with like 250 meter hub heights or on like 200 meter blades? Is this going to be the reality, or are we at the optimum level? So are we at the plateau? How is the wind industry and wind turbines going to grow? Then I'm going to have one other question for you, but I believe these are the most interesting ones for a lot of people.
Perfect. Thank you very much, Ibrahim, for having me on today. Let me just share the visuals. I hope you can see the screen.
Yes.
First of all, a short introduction. So Till Jung is my name. I'm from the Nordex Group, responsible for product strategy and sales support. So defining new products and then supporting our commercial sales people with the technical support behind it. First of all, thank you very much, Carolina, for the very interesting discussion. When I started at Nordex, I'm there now a little bit more than 10 years ago. I actually started in our offshore business, which doesn't exist anymore. But it's really fantastic to see how this offshore industry has developed over time and what's possible today and the outlook that we are seeing there. For those of you that don't know Nordex, just very brief intro. We basically do the whole chain of activities in onshore wind. We build turbines, we install them, we plan wind parks, and we do service them. So that's basically the overall scope. And we do act as a global company. We have production hubs across the world. We're a little bit more than 8,000 people on board, and we do also produce in Turkey together with our partners blades, and also source components locally. So a very strong presence in Turkey, where we are onshore market leader. And of course, in the end, that's the outcome. Just two pictures to show you some recent installations that we've done on the left side, the N163 5.X turbine, and on the right, the picture, not even a month old, our latest edition, which is the N163 6.X prototype. So that's where we are right now, above 6 megawatt. You asked a little bit about the sector, and I think the news around the onshore sector have been, let's say, difficult. I would call it in recent months. A lot of profit warnings from industry peers, and I think it's important to recap a little bit. Okay, what's happening right now and what is the outlook? Because there's a big distinction. I think when we look at the last years, we've gone as an industry and as a sector through 4 main phases. First, we started a rapid innovation cycle, and what you see here on the screen is, of course, part of that. We entered a price war with other OEMs, driven by introduction of auction systems. We then had COVID, like many other industries, with all the impacts that had. And now we are faced with since some time with a very high increase of volatility on commodities, logistic costs, etc. And you just saw our global footprint, and you can imagine that this is, of course, a challenge. And now, of course, on top, and you mentioned it earlier today, the turmoils caused also by the war in Ukraine. So all of that, has been very challenging for the sector and has dropped profitability across OEMs significantly. So that's kind of the status that we're in. But on the other hand, one thing is today, and the other thing is the outlook into the future. And if you look at where we are, then I would like to show you on next slide a little bit where we've come from and what the result is. And that will also bring us to the technology question. So if you look on the left side, you see our turbine of the Nordex Group in 1987, which was an N27-250. You actually see it on the bottom left here. And we just recently put it next to our newest machine to give you an idea of the size. Now we are 25 years later, and we are installing, 35 years later, and we're installing N163 6.X, which we just installed here in May 2022. So there has been a huge innovation cycle going on over the last decades. And the result, and here I'm only showing 10 years, of course, you can imagine that the curve was much higher, even on the left. We have reduced cost of energy over the last 10 years. It depends a little bit, which source you ask, but common understanding is more or less around 60 to 70% cost of energy reduction over the last 10 years. And this has led to a situation where if you build new capacity, wind and solar, which is kind of going the same way, are the most competitive energy sources today. And if you combine that with the situation that we want to, fight global warming and decarbonize our industry and the energy generation or overall power generation, and then of course we are in a fantastic spot right now. If you look at the forecasts that are necessary to reach this, we're talking about doubling, tripling the onshore installations on top of what's coming offshore, as Carolina pointed out. And so, we need to overcome as a sector the current challenges, but the outlook is fantastic. And I think that applies to Turkey. There's big plans for Turkey, but of course, that's basically the case across the world. We're seeing very, very few places where installations are targeted to go down. And of course, that raises the question, as Ibrahim mentioned, how big will we get? And I would like to start with a small anecdote, because I just mentioned that I started in offshore in the Nordex offshore department a little bit more than 10 years ago. And at that point in time, we started developing a turbine, which was supposed to be one of the biggest in the market in offshore. And it had a rotor of 150 meters and a rating of 6.0 megawatts. So that was at that point in time considered crazy big and impossible to ever build onshore. Yeah, so that was only planned for offshore. And you see the picture on the bottom here. Just 10 years later, we're installing larger machines with even higher ratings onshore. So what I'm trying to say is, if somebody tells you X and Y is the limit onshore, there's a good chance that person will be proven wrong over time, because there's always some innovation. Nevertheless, there's of course some considerations onshore which are different when we talk about offshore installations. And the main part is of course logistics. So when we're talking about development of onshore turbines, we are always limited by delivering turbines from a production site to an installation site. There's some things that you can do on site. We, for example, produce towers on site with a concrete technology, but otherwise you have to transport. And that is, of course, limiting it to a certain degree. Now, when we look at the sector, again, taking a step back, we've seen that the innovation over time was rapid. So in the last years, you can say more or less the OEMs released one new rotor every year to the market on average. We've seen that while this has significantly reduced the cost of energy for customers and for society, and has brought us, to this situation now where we think we can be one of the main contributors to fighting climate change. It has also caused some problems because the innovation was so quick that we introduced new models, and only 2 years later, the next model was coming up, taking its spot. And this clearly is one of the contributors that we've seen to the low profitability of the sector. And I think it's by now common sense in the industry that this innovation cycle cannot continue to be that quick, because basically the new turbines don't pay back. So there is probably going to be a certain slowdown in terms of growth of turbines. So that's, let's say, the more commercial view on it. The second one is on the technical side. And the question is, can they get bigger? First of all, the answer is yes, they can get bigger because there's technologies available. You can split the blades, you can split the hub and the nacelle in different parts. So there's some ways of doing it. The question is only, does it really pay off or not? In the past, or what we're seeing now is that basically with every growth step that we do, the cost rises exponentially, and it's more difficult to reduce that cost of energy curve as steep as we had done in the past. So when we introduced the Delta 4000 platform with a 149, I think we were targeting something like 20% cost of energy reduction, which is very, very significant and was a huge step. And in the latest models, we're more talking about high single-digit terms. So basically, the added value of these kind of new turbines is slightly decreasing. And we've even seen in certain cases that also among our peers, basically new turbines were introduced, but they were not beating the old mature technologies in terms of cost of energy, and we're just not better, not delivering value to the customer. So, I think in essence, to maybe trying to answer the question without giving an accurate outlook I think there will be a split. There will be some markets where turbines are continuing to grow, especially if you're looking at the targets that certain states have done and the limited space they have. Then the only way is to go higher and bigger, etc. And there's other markets where we're only looking at cost of energy, where probably the current very efficient, very mature existing supply chain turbines will continue to be around for a little while. So that's let's say with a little bit more context. I think the answer: can they grow or will they grow? And of course, Carolina will know more about that. Offshore, most of the things that I talked about are not applying, so it's a different story that we're seeing offshore. And I think the latest turbine size we've seen offshore is above 230 meter rotors being planned.
So it will be as you mentioned. Thank you for answering it. Although it's kind of political, but what I understood is most probably we are going to see increase in size for certain areas. Of course, for first it will be for offshore, but also for certain areas in the globe. we will be able to use those larger turbines. But in some areas, especially due to logistics problems, we will be continuing with a slight growth with the existing technology. And I mean, one other critical thing that you mentioned was the additional added value. Of course, I mean, it's going to reach, as expected, all technologies are going to reach a plateau where any additional development there in size, etc., would add less to the LCOE or overall electricity price. So thanks for summarizing it. I will add one more thing. I mean, I'll ask you to add one more thing about hybrids, maybe shortly, because we are a bit ahead of our time. How do you see hybrid technologies evolve together with wind?
So I think, you know, hybrid technologies in terms of, you know, co-location of wind and storage, etc. This will
maybe even solar.
Yes, and solar. It will probably grow, and I think, you know, we have a few panelists here also today, which will talk about it, also in connection with hydrogen, etc. What can be done there, and what the outlook is there. I think it depends. What we are seeing is it depends a little bit on the location. So there are areas in the world, or regions, or whatever you want to call it, even sometimes only specific wind parks, where it makes sense to co-locate wind with solar or storage. But usually the only time that makes sense is if you can create synergies, because otherwise you can just, you know, put solar on one place, wind on the other, and have a grid connection in between. And usually those synergies are with, you know, with certain savings in the grid connection, or because there is you know, some savings because you use the same space, or you save BOP costs in the wind or solar park. So we do see this overall growing, but it is very regional where we see this making sense. A good example is Australia, which has a combination of a rather weak grid infrastructure combined with a very nice fit between when the wind is blowing and when the sun is shining. So, you know, it's very seldom that both are on full power. And so they can share perfectly well a grid connection, especially in connection with some storage. So under these conditions, it's perfect match for a co-location hybrid. In other cases, you know, it makes, let's say, less sense. If you allow me, then maybe some addition to the question beforehand, with regards to, you know, added value, because we're always looking at, you know, the rotor and the rating, because that's the most obvious thing in onshore wind. But I think there's many things around it which can still be improved significantly, and there's a lot of activities also in the sector ongoing to create value from something which is not the rotor and not the rating. The towers are a very good example. You know, there's a lot of innovation in tower and installation methodologies where you don't need cranes, etc. There's a lot of work ongoing and in terms of improving operations, because what you do today is you plan a wind park based on some measurement data that you have for let's say 6 months, a year, or 2 years, and then you basically rely on that, put the turbines down there, and leave them for 20 years and service them. But, you know, in the meantime, you learn more, you have more software development, you develop new control algorithms. So there's a lot of improvement that you can do during the operating time of the asset and generate more value for the customer. And then, of course, there's a lot of challenges in the industry that we need to solve when it comes to circularity, when it comes to recycling, when it comes to green steel. So when it comes to all these factors, which, while we always think, you know, we are, you know, very sustainable because we're building wind turbines, our product also needs to become more sustainable. And then there's a whole different area with regards to cybersecurity and SCADA integration, etc., where there's also a lot of innovation happening. So, you know, while the whole sector has been focusing only on turbine developments, not only, but on a lot of turbine developments in the last decade, I think there's a lot of other issues that that we'll be focusing on in the next year and improving a lot, and thereby also creating a lot of value. And maybe one last point is when we talk about the targets of onshore wind and of offshore wind, we will of course see a much higher penetration of volatile generation power in the grid. And so, you know, developing turbines which have a superb grid compatibility and you know, can support the grid in a certain way is of course one of the tasks that you know, grid operators or in one way or the other also society will put on our table to become better and create innovation in that forum. So I think there's a lot of things to work on now that we have already done this huge step here in turbine evolution over the last years.
Yeah, I mean, one major difficulty, as you mentioned, will be there will be lots of other technologies to be coupled with wind turbines, either at the substation level or maybe at the turbine level, individual turbine level. Because, you know, as the size goes bigger and bigger, we are opening up larger areas for the installation and for the maintenance in the future. Those areas most probably will be used even at turbine level for, I mean, storage, for hydrogen, or for solar. And any additional technology integration means that, I mean, hardware and software solutions. So there, I believe, significant challenges up to come for turbine manufacturers. It may also bring an opportunity for you. Maybe later, I mean, if we are going to have time for Q&A, you can add more on that one. So yeah, thanks again for Till. You had great contribution against about turbine developments, where we are going to go, and my interesting question was answered anyway. Thank you very much. So now we are switching to Vasiliki. And Vasiliki is going to talk about the battery integration, energy storage integration with renewable technologies, with wind, and how it's going to affect and what opportunities we are going to see with further integration in battery storage. You may also at the end add some about what kind of permitting challenges, planning challenges we may face with in the future with more renewables and battery up to come. Okay, thank you. Floor is yours, Vasiliki.
Thank you very much for the introduction, Ibrahim, and thank you very much for the invitation and for organizing this very interesting discussion. So my name is Vasiliki Clonari. I'm the head of energy system integration at Wind Europe. So this is a recently built unit at Wind Europe. By the way, Wind Europe is the trade association of wind energy in Europe. So our team is a team of analysts, so engineers in this case, looking into system integration aspects, so grid planning, grid connection, regulation for all these topics, digitalization, cybersecurity, and electricity markets. I am Greek, located in Belgium since 10 years now. So yes, today I would like to talk about the integration of storage, but a bit more specifically battery storage with wind energy. I guess you can all see my screen. Okay, please let me know if not. Wind Europe, in the wind industry in general, we see battery storage as one of the major enabling technologies for Europe to reach its decarbonization targets. And of course, there are many reasons for this, but here on the screen, I have tried to list the ones that we consider, the applications that we consider as the most important ones. So first of all, we see a major role for battery storage in addressing evolving energy system flexibility needs. So with the ongoing electrification of demand and deployment of renewables, these flexibility needs will be increasing, and we see, as I will explain also in the next slides, we'll see a big role for storage in mitigating this. Then the second important role is in grid scarcity, which is today a problem in many countries in Europe, but not only. I think it's a more international issue. Then the third one is something that has become very important these last months. It's energy security and security of supply, more specifically. And of course, we also see a major role in the direct electrification of transport. So last year, in 2021, we published a report which is called Getting Fit for 55 and Set for 2050, together with the Active Wind platform, in which we have dedicated a chapter in flexibility. So we, based on this analysis, we, as I mentioned before, with ongoing electrification and the deployment of renewables, variability in the power system will increase, will keep increasing, and this, of course, will means that the residual load, which means the total demand, if we subtract the what will be supplied by renewable power at every moment, will also be increasing and be very variable. So we have tried with this chapter to list which are the enabling technologies that we see in the future for mitigating this variability, this increase of the residual load, and which are also compatible with net zero deployment. So in this graph, you can see these technologies. Today, most of these needs are actually covered by what we call here dispatchable generation, which of course in a very big part is thermal power plants, so what is often called conventional generation. But going towards 2030, 2050, we think that these roles be undertaken by other technologies such as cross-border transmission, interconnectors. State-of-the-art variable renewables can play a major role in this. Demand response in different ways, of course, storage, and including short-term and long-term storage. And as you can see here, actually what the graph shows is also the timeline, the different time cycles where each technology can contribute to flexibility needs. And as you can see, battery storage, including both stationary and vehicle to grid applications, and long-term storage, can actually cover the full range of flexibility needs. So battery storage is, of course, mostly focused on flexibility needs from seconds to maximum one day, I would say. In general, what we support is that we will need to make sure that we have a large and diverse portfolio of these resources in the mix, so that which means that we need to make sure that we have investment signals for having this mix of technologies to be able to mitigate this variability in all time frames. And so when I talk about battery storage, here I mean both standalone applications, but also battery storage integrated with variable renewables, new assets or existing assets. The benefit of battery storage is that it can undertake multiple tasks at the same time. So in this graph, you can see the list of applications which are served by battery storage in the United States. You can see it's a very big list of applications. And then actually, if you look more into the detail, it shows in its state for which applications it is mainly used. So this is actually to show how the potential of this technology. But of course, this is another market. It is not a European market, but the applications, of course, could be deployed also here. So in some markets in Europe have advanced more than others in the use of battery storage, but in general, the landscape is not yet where we think it should be, considering the big potential of this technology standalone or combined with renewables. Last year, ideally the different applications should be deployed with a remuneration. So in the form of ancillary services, so that the developer or the investor or the owner of a battery storage assets can have a way to monetize this kind of developments and investments. So last year we did an internal survey with our members, Wind Europe members, to see where actually we are in the European markets with the deployment of this kind of ancillary services or contracts. Actually this slide just shows an overview of 3 markets. So the UK, Denmark, and Germany. And and it actually focuses on the participation of storage, in the possibility for storage to participate and get remunerated for by offering services. It focuses both on frequency-related ancillary services, so the first 4 lines here, but also on other services like voltage control or other. So what you see here in green, the boxes that are in green, they mean that this service is indeed deployed as a service, as a remunerated service in the country. What is here in yellow, it means, and that storage can participate and has an adequate remuneration, which is of course very positive. What you see here in yellow is that indeed this exists as a service, but for different reasons, depending on the case each time, it's not interesting or enough adequately remunerated for storage to participate in the services. What you see in red means that storage cannot participate in the service, and what you see in brown means that the service does not exist. So, for instance, here you can see that the UK is a quite good market for this kind of services for the participation of storage. Denmark is a good example for the frequency-related services, but not for the rest. And there's a similar situation in Germany, even though I think even in these markets the situation is improving. So ideally, this would be a very good driver for scaling up.
Vasiliki, just to ask kind of clarification question. Why? I mean, this shows Britain to be a quite developed battery storage market. Why do they have such a developed storage market while the others doesn't have? What is the difference in Britain?
So this is actually is not really showing the storage market. It is showing the ancillary services market.
Okay, sorry. Okay.
Which has as an outcome the fact that battery storage can participate and get this contract is of course very positive and helps advancing also the battery storage market. I think what has led this is that well, some countries have advanced more with the integration of renewables or with electrification, so they had some of these needs before others, or they couldn't maybe count sometimes on certain resources to to cover these needs. So necessarily it led as a market development in more storage applications.
Yeah, I mean, so that means British market anyway for battery storage investments have a wider opportunity basis, while the others doesn't have all such opportunities for battery storage.
At this point,
in ancillary services, of course.
Yes. At this point, yes, but it's more interesting for based on these services for an investor to invest in battery storage in this country. But of course, the markets are evolving and these things are changing quite fast. So we are optimistic that it will also evolve in all the countries. And there are already many developments. For instance, I know that in Italy, since last year, there is a new capacity market for batteries, which has really driven very quickly investments in battery storage. While we did this survey end of last year, so things have changed since then in other countries. And this is also interesting to follow. The second point I mentioned in my first slide was about grid scarcity. So what you can see here on this slide is the redispatched and curtailed volumes of renewables in Germany between 2013 and 2020 and their respective costs. So you can see that this has been increasing. In 2020, it reached 1.2 billion, and I've heard that based on the results for last year, now it reached 2 billion euros last year, which is a huge cost, and it's actually a cost of managing the current grid in order to be able to host as many renewable generation as possible. And of course, these costs of managing the grid are very much related with how much grid capacity is available. So if the build out of grid capacity does not follow the pace of electrification and renewables deployment, necessarily we have much higher congestion management costs. And I will connect this to storage, and this next graph, actually, in some electricity wholesale markets in Europe, negative pricing is possible. So as a generator, at some certain moments, you might be paying for supplying your energy to the system. And even though this huge increase in prices that happened in 2021, you can see here that the number of hours with negative pricing has actually increased. This actually generates uncertainty for investors in renewable energy because it's difficult to predict how much it will increase and what will be the revenues if this increases over the long term. And of course, it has a big impact on renewables because they are weather-based generation, so they're very much dependent on the weather resource and affected by. It's not they're not dispatchable as other generation technologies. And actually, this increase of hours with negative pricing, it shows the increase of hours with oversupply of power, which happens because there are some generation technologies that are inflexible, some thermal power plants or nuclear generation that cannot or does not have an interest to shut down in hours of oversupply. Or of course, the fact that the grid is not enough, the grid capacity to host this additional generation. And of course, for this problem, but also the weak grids that was mentioned before, we think that storage could play a very important role in reducing both the congestion management costs or this type of uncertainty for investors in storage. So this was the second point that I mentioned, the grid scarcity leading to such issues. The third one is about energy security, or more specifically security of supply. So in many European countries, there are I think it's half of the member states in Europe today that are already deploying this kind of mechanism that is called the capacity remuneration mechanism, or considering to deploy that. It's a type of long-term contracts with certain assets, generation assets, that should kick in case of a significant scarcity of supply. And the graph here shows that these kind of contracts are, until now, they are dominated by generation, like natural gas, coal, lignite, or nuclear. And usually these are contracts of 10 or 15 years. So meaning that, for instance, if such a contract was awarded in 2020, it will last until 2035, for instance. While other technologies we believe that other technologies could, of course, participate in such mechanism, especially renewables combined with storage, or even storage standalone, of course, also interconnectors and other technologies that are much more compatible with the net zero target in Europe. So and of course here again we see a major role for storage in this kind of market mechanisms. The last point that this last important role that we see for storage is, as I said, the direct electrification of transport, so the electric vehicle charging use cases. The graph here shows some scenarios that were made I think last year by ENTSO-E, the Association of Transmission System Operators in Europe, and it shows how they believe that electric vehicle charging infrastructure will most probably develop in Europe, what grid reinforcements will be needed for that, and what will be the flexibility potential per case. So apparently they see a big role for home company fleet and public charging stations, which have also the highest flexibility potential. Then for bus depots and night charging, and also for fuel station models, but with electric vehicle, with charging, of course, devices. And then for highway hyper hubs, so the last two options are more for fast charging, which actually have also a lower flexibility potential because of the short time that they are used for. This is just an example of there are new companies and new business models in this area of the electric vehicle charging, where for instance, this company Calista Energy is building a network of electric vehicle charging that is directly powered by wind and solar energy. So this is also a market that is emerging, and of course it's very much dependent on the battery storage market. Yes, and I would like actually to finish with the barriers to the scaling up battery storage integration today in Europe, but I think these are more general issues. So the first one is the lack of a regulatory framework for storage, or insufficient regulatory framework for storage. In most countries, storage has not been established in the regulation, which of course makes it extremely difficult for a developer to get a permit for that, or to include it, or a developer of renewables to include it in the installation. And of course, I mean here implications on the grid connection rules, operation of these assets, and which becomes, of course, even more complex when it has to be combined with other technologies. And the second big barrier is the insufficient market signals to drive investments. Today, storage projects are actually developed in a fully merchant way. There is no, for the moment, mostly no state aid for such projects. We think it's a developing technology, so it would be useful to have some tools We also see a role in limited auctions of renewables together with storage, especially in areas where we have grid scarcity, structural congestion problems since many years. And in general, we see a need for long-term signals for investments in battery storage, standalone or collocated with renewables. So this was an overview from my side. Let me know if you have any questions or comments.
Thank you for your presentation. I mean, apart in addition to the standard battery storage presentation and relevant expectations, thank you for elaborating some about the EV charging. We see, because we also see similar developments in Turkey, although the EV market in Turkey is a bit behind of Europe. I'm sure we are following, and seeing significant signs of the EV market starting to grow fast and fast. So the charging infrastructure there is on a fast growth, and it seems there are similar companies investing in hybrid charging, like to link it with solar. I haven't heard anybody considering wind, but most probably it's also going to evolve. But those needs to be coupled with battery storage. Otherwise, it will be very difficult. I mean, to charge anyway. So it's not going to be a solution by itself. So thank you for your comments. So now there are questions coming. If there will be something related to you and your presentation, I'll share it with you later on. So now it's Matthias who is going to take the word, and he's going to talk about hydrogen integration with renewables, and especially, of course, the green hydrogen, which definitely is our target to dominate the market. So floor is yours, Matthias.
Thank you, Ibrahim. And everyone, good to be here, although only virtually. But I think hydrogen is a topic, if you are working in renewable energies these days, it's difficult to pass 1 week without at least hearing the word once. And it's talked about in a lot of different senses. And my goal for today will be to, well, answer 2 questions. One, what will be the role and the main impact of hydrogen in our future? And B, how big is the actual potential? I have a small presentation, and I will try and share my screen and hope this works out as well as when we tried. So can you see my screen?
Yes, we can see it.
Okay, great. Before I start answering the 2 questions that I just raised, I want to say a quick few words about Fichtner. So Fichtner is Germany's largest independent engineering and consulting company. We also have an office in Turkey, in Istanbul, with around 20 people that started in 2008. There we do a lot of wind, actually. And today, I think my focus will not be the wind side, but the hydrogen side coming from that, and giving you my idea how this will integrate with wind. What does Fichtner do in hydrogen? We have a long track record with hydrogen. We started in the early 90s, and since the hydrogen industry took off around 4 to 5 years ago, we've had a strong growth because of that track record. As you can see, we've done projects in most continents except North America in the last 4 years in hydrogen, more than 50 projects from kilowatt to gigawatt scale, and planning and procurement, actual engineering projects, one that is being built today and will go later into operation later this year. We have 4 currently under contract with us, smallest one being 5 megawatt and the largest 100 megawatt. And since we have such a long history with hydrogen, and as you can see, we are quite active, we do not only want to be a consultant that, well, does engineering jobs in the sector, we also want to contribute. we do two more things, therefore. We have our Fichtner Forum Hydrogen, which is usually a small group of high-level decision makers. We've started this in 2019 with major companies from all over the value chain. And this year's edition will be hosted in Santiago de Chile later in the fall. And since a lot of the questions, when people talk about hydrogen all the time, repeat themselves, we also have compiled what we think someone working in the industry should understand about hydrogen in our handbook for investors and project developers. And with that, I'll leave it at the company presentation and dive right in. When we talk about hydrogen, there's two ways to look at it. One, I've heard this word hydrogen as a storage before. Usually people think about hydrogen as an electricity storage. So taking electricity, producing hydrogen, producing electricity, as we just heard from Vasiliki also, not an hour later, but after days, weeks, and months later in the year. That's the first business case or way to look at hydrogen I want to discuss. And then there's another way, which is hydrogen as a commodity, but I'll get into that later. So how does a system on a very basic level look that is a hydrogen electricity storage? You produce renewable energy. In this case, for example, 1 megawatt hour. You have an electrolyzer, which splits hydrogen into, which splits water into hydrogen and oxygen. And you have a gas tank, a pressurized tank where you store the hydrogen. An electrolysis based on lower heating value has an efficiency of around 65% on a system level. So this means you're losing around of a third of the actual energy in the conversion of hydrogen, of renewable electricity to hydrogen. And if you want to produce electricity again, you need a fuel cell, combustion engine, gas turbine, different options with an efficiency of, let's say, more than 50%, but not more than 60%. So, and if you look at this chain, you see that you will lose around 2/3 of the energy going from electricity back to electricity. And you see that you have a couple of equipment types involved there. Another way to look at this is if you plot the cost of producing hydrogen over the actual operating hours of an electrolysis plant. So on the x-axis, you see here annual full load operating hours, and on the y-axis, you see how much it costs just to pay back the electrolysis, so the hydrogen production plant, with electricity prices of 0. So if you take curtailed electricity and you produce hydrogen, you will still have costs because an electrolysis plant is costly. As an example, if you do this for 2,000 hours a year, you see here that you will have around 110 euros per megawatt hour of hydrogen produced as costs. And then you remember the previous slide. If you produce electricity again, you need, if you want to get 1 more megawatt hour out, you need 1.8 megawatt hours of hydrogen in, so 200 euros at that. And you have to pay off the fuel cell, which gets you to 350 euros so per megawatt hour. So in our example, if for 2,000 hours a year, which is a lot, you have electricity curtailed and you have an electrolysis, a tank, and a fuel cell, getting out 1 megawatt hour of electricity, just the cost to store that 1 megawatt hour would be 350 euros. And this is a lot. And maybe it's strange that I, as someone who has spent most of his professional life in hydrogen, is saying that using hydrogen as an electricity storage is quite expensive, and it doesn't fit well with what you see every day, that people are talking about hydrogen as storage, as kind of the future of our energy systems, if you ask some people. And the answer is, hydrogen is an electricity storage. So electricity in, hydrogen, electricity out, locally only works under very specific circumstances, as you can see from the numbers. But, and that's why I said there's two ways to look at hydrogen. There's another way to look at hydrogen, which makes it incredibly attractive. And the reason is, if you think about the goal that we have, if we want to achieve net zero by 2050 as humanity, if you look at the power and heat sector, it's only a quarter of actual greenhouse gas emissions. And if hydrogen is just in that dark blue quarter of the circle, then it's simply a very expensive storage. But the promise of hydrogen is that it can help us work on the other 75% of emissions that we have. If you look at this another way, I here have a chart that shows you the final energy consumption of the EU 27. Final energy consumption is what all of us use. So this means if you plug in your smartphone, your computer, your refrigerator, your final energy is electricity. If you fuel your car with gasoline, your final energy is gasoline. So, and what we can see here again, around a quarter of the energy that Europeans use is electricity. And a bit more than a third of that is renewable electricity. But what we mainly use still today, and we are learning that with the Ukraine situation, again, especially as Germany, is chemical energy. We use gas in our homes, we use fuel in our cars, we use coal in some places to heat still, but we mainly use natural gas in industrial processes, for example, in steel making, in chemical industry, in fertilizer industry. So there's a large potential for decarbonization to be unlocked, and that we need to tackle. And hydrogen allows wind energy and allows renewable energy to access these new sectors, because without a chemical energy storage, we are confined to those 25%. And once e-mobility grows a bit more and a bit more and a bit more that we have here, we saw heat pumps. So there will be parts that will be electrified, but great parts of these 62% will not be electrified also in the future. And this is the actual business case. Hydrogen as a commodity. So storing renewable energy from renewable electricity in hydrogen gives it access to a lot of new applications. We've heard about direct use. There's, for example, a study in the UK and the national plan, and also a study that we did for a large city in Germany, where simply the amount of houses connected to the natural gas grid and the building stock does not allow you to electrify heating. So we will still need some form of gas to heat our homes in the future. Fuel ammonia, if you look at what Japan and Korea are doing, Japan and Korea both have the problem that they don't have enough renewable resources to achieve their decarbonization targets. And Japan is actually already tendering fuel ammonia contracts for use in their thermal power stations, because otherwise they will not be able to comply with their decarbonization targets. The fertilizer industry. Sometimes if we speak about hydrogen, we always think hydrogen is green and helps us save the climate. It can, and that's the purpose of what I'm talking about today. But we already are producing a lot of hydrogen. We are producing 70 million tons per year, and the amount of carbon emissions of that is more or less the same as the entirety of Germany. And half of that goes into the fertilizer industry in the form of ammonia. And that's why we all of a sudden see green fertilizers, green ammonia, because that's a sector that needs to be decarbonized. Methanol, a chemical that is used in many industrial processes and can be used for synthetic fuels. For example, if you think about decarbonizing airplanes, we still have a lot of airplanes even after COVID, and those will not go out of service anytime soon. Airplanes have economic lifetimes of several decades, and we need something to fuel them with. And there's currently no other alternative for the existing airline and car stock than synthetic fuels based on green hydrogen. And then we've already heard green steel, green products, not only as an input into wind turbines, but especially in consumer products. So you see, there's a lot of sectors that have been closed off to wind energy and renewable electricity in the past that hydrogen can open the door for. And that is why all of a sudden we see major players developing larger and larger and larger hydrogen projects. I'm presenting here just the history of typical announcement of green hydrogen projects in the last 5 years. In 2027, in my home state in the south of Germany, we have proudly announced a 1 megawatt PEM electrolysis lighthouse project and felt pretty good about ourselves. Until a year later, in northern Germany, in the Heide refinery, a 10 megawatt electrolysis was announced. Then in 2019, the German grid operators got together and announced 100 megawatt projects. And then in 2020, all of a sudden, international players announced gigawatt projects, most of them based on wind. And in 2021, Fortescue Future Industries, for example, has announced a portfolio of in the tens of gigawatts of green hydrogen. So you can see how this is going forward, how this is growing. And most of this is not based on taking hydrogen to store wind energy and then re-electrify it. But for example, Fortescue has Covestro and E.ON in Germany with letters of intent for offtake agreements, as you may have read in the news just this year. So it's going into the industry, as I showed, and it's getting more global and global as we speak. As we know, energy flows are global to this day, and they will remain global in a decarbonized world. In Germany, we had the idea of being energy self-sufficient just from renewables. It's getting another push with the Ukraine crisis, but we are still talking about importing energy, and we need to import carbon neutral energy. And that's why not only Germany, but Europe, Japan, major consumer countries need to import green energy. And that's why, as I've shown, bigger and bigger projects for the export and supply of green hydrogen to consumer countries are being developed. And I want to close with, just as I said, my second question to answer is, what is the potential? And I've already shown you that with the 62%, I assume and I believe that the potential of hydrogen in the future, decarbonizing chemical energy, can be larger than today's renewable energy sector. So what is the potential hydrogen market size? This is the hydrogen market today, the 70 million tons I referred to. And that is a market of around $100 billion worth a year. And that is just decarbonizing the existing hydrogen applications. If we now take the fossil fuel market that we have, and I've shown the fossil fuel direct use, if we take this market, it becomes a number with a lot of zeros. So what I want to close with is hydrogen can be a storage for electricity over time, but mainly hydrogen is a storage for renewable electricity, to make it accessible for other sectors that renewable electricity have not been able to conquer yet. And with that, I want to close. If you are interested in working with Fichten in the Turkish market, my colleague Sajid is the guy to talk to. And if you're interested in learning more about how we think about hydrogen, please feel free to follow us on LinkedIn or see our website for the topic. We regularly write about it. As I said, we actually are passionate about hydrogen and we want to contribute to its development. And with that, I want to stop sharing, and I'm curious if this has raised any questions that you would like to discuss.
Thank you very much for this summary. It was quite interesting and I mean opened up new questions, new thoughts on my mind. I'm sure it created new thoughts on the listeners' minds. And questions, related questions are also coming. Sajid, by the way, is one of our board members and also the deputy chairman of Turkish Wind Energy Association. So it's good to have him on board. Just to summarize your speech and also Vasiliki's comments, it seems both battery storage and hydrogen will bring a lot of opportunity also for the growth of renewables. While there's going to be huge markets, especially for hydrogen, direct use of hydrogen, or maybe secondary use of hydrogen. I mean, the numbers are impressive anyway, but there is going to be interesting developments in the future. Battery storage most probably will help us to continuously operate renewables, while with hydrogen we can add more and more capacity. In fact, not only to supply the grid, but also to generate hydrogen and other related products. So it brings endless opportunities for the investors and for the world. So coming maybe to the final speaker of our panel, I believe we have decided at the beginning the right path from Carolina and until to Guy, because how he can contribute now is about PPAs, and on top of the technological developments which will support renewable growth, wind growth over the globe, there is also the market size of the supplementary mechanisms. So PPAs and other market mechanisms, if you want to contribute also on those, are going to help renewables to grow on top of all those technological developments. So floor is yours, and we hope. I mean, we are open to listen your comments, your valuable comments, and your presentation now.
Great, thank you very much. Good afternoon, everyone.
Welcome.
It's a pleasure to be here talking about PPAs. My name's Guy Brindley. I'm the head of market intelligence at Wind Europe, so the same place that Vasiliki works. So I won't give you an introduction of that. It's the the Association of Wind Energy in Europe. So I'll get straight into my presentation, and let me just share my screen. Hopefully you should see that. And okay. So let me start at the beginning. What is a corporate renewable power purchase agreement or a PPA? So PPAs have been around for a long time. It's what utilities have been using for many years to purchase electricity from generators. But now we're talking about a long-term agreement between a corporate, so the buyer, and a renewable generator directly. And why is that important? Well, renewables have a variable output, and they're also sell their electricity on a market with a variable price. This means that revenues from renewable generators can be very uncertain. But in fact, we're actually quite good at predicting the amount of energy that a renewable generator will produce. It's a lot harder to predict market prices. So this is where PPAs and other forms of support, such as the two-sided contract for difference or feed-in tariffs like you have in Turkey, come in. So you can see on the chart below, you have a PPA price there. And what I'm just trying to show you there is a corporate can sign up to these long-term agreements, and they can sign up and commit to buying all the power at a fixed price. And this gives renewable generators a lot more certainty over the revenue they're going to produce. Again, why is that important? Well, here you have the two counterparties, but there is a third, and that's the banks. So renewables have a high upfront cost, and developers often need to borrow money to construct a wind farm. Now, when a bank can see that a renewable generator has a certain flow of income, they're more happy to lend money. So whether it's a long-term PPA or support from the government, that sort of confidence allows banks to lend cheap debt, which allows renewable generators to be financed cheaply and therefore to be built. So they are very important. Now, quickly, I'll talk about the structures. So in the following diagrams, we have the following elements. So you have your electricity flow, that's the electrons in the grid. You have your cash flows, and then we talk about the balancing electricity and cash flows. And finally, the guarantees of origin. These are the certificates which prove that you are buying renewable electricity. In Europe, most of these certificates are guarantees of origin. In Turkey, I believe you use the International Renewable Energy Certificates, the IREC standard. But they're the same thing, they just prove as a buyer that you've purchased a certain amount of renewable electricity. So the two most common structures are the physical PPA. So here, the renewable generator will enter into a negotiation with the corporate consumer. They will decide a price together of the power that's going to be sold. They have to be on the same grid. So there is a direct link between the electricity which is being put into the grid by the renewable installation and the power which has been taken off by the corporate consumer. But as I said, renewable generation is often variable. And it's probably not going to match exactly, or almost definitely not going to match what the corporate demand for electricity is. So essentially there's an intermediary, an energy service provider in here, which will balance the difference between the generated electricity and the demand from the corporate. This is known as sleeving, hence why sometimes a physical PPA is also called a sleeved PPA. And you can see that the energy service provider also supplies that guarantee of origin, or the IREC in your case in Turkey. So that's been the most common form of PPA. And there is another version which is more common in the United States and is becoming more common in Europe as well. And that's the financial, often known as the virtual PPA. So in this situation, the corporate consumer and the generator don't actually have to be on the same grid. Essentially, again, they enter into a negotiation to decide on the price, but they buy the power, the corporate buys the power on the grid they're on, and the renewable generator sells the power on the grid they're on, and between them, they settle the difference between the prices that they paid or sold at. So in essence, the renewable installation still gets that fixed price, even if it's with a balancing payment from the corporate. This has the advantage of allowing more flexibility, and it enables actually cross-border PPAs where you can sign a PPA for a renewable generator in a different country to the one you're in. And corporate PPAs aren't traded, they're not a standard product. And part of the reason is there's many risks associated with them. I'm not going to go through these, but this is just a list of the sort of risks that need to be considered. And if you're a corporate, you've never really come across any of these risks at all before. So there's a lot of education that needs to be done, and there's a lot of negotiating that has to go on, basically to assign the various risks to the different counterparties and to see where risks can be mitigated. Now, the importance of PPAs. So I had a look at this for this presentation. This chart gives you the proportion of financed capacity of wind farms in Europe, which have been financed by PPAs. Now, it's a rough estimate. I've not gone by project, but I've just looked year on year, what's the volumes of PPAs which have been signed for new projects, and what is the financed capacity for new projects. And you can see a clear trend. So in 2015, only around 2% of new projects were financed with a PPA. And last year, we're looking more at 14%. So it's getting more and more important in Europe. And you can see by my next chart that the market is growing significantly. Two things to note from this. So this gives you the annual volumes contracted of this. To be clear, this is renewable energy, so that includes solar. And you can see a steady growth. This is, yeah, so it looks like a cumulative chart, but it's not. This is annual, and 2021 was a record year. I suspect that there were some delays from 2020, which has lowered the 2020 amount and increased the 2021 amount, but it's still clearly growing. The other thing to note from this chart is the diversification of the countries. So each of those colors are a different country. And you can see by 2021, we have, I think, 11 countries there, maybe. I think it's 11. But in the earlier days, there was just 2 or 3 countries signing PPAs. How does this look from a technology side? So this chart gives you the same information, but instead of by country, I've split it by technology. You can see yellow is utility scale solar, dark blue is onshore wind, and light blue is offshore. And then I've got a green section in there, which is for portfolios. So utilities which have a portfolio of solar and wind, usually, sometimes some hydro, and they will sign a corporate PPA. Again, a couple of things to point out here. Firstly, you can see that in the early days, it was almost all onshore wind. And in the last few years, there's been development of solar PPAs and offshore wind PPAs. Plus, last year, we saw quite a lot of these portfolio PPAs. As an example of an offshore wind PPA, I give you here the Borkum Riffgrund 3. So this is a 900 megawatt project being developed in Germany. This was one of the zero bid projects, and you can see that they have coverage of around 87% of their volume now by corporate PPAs. So this is an example of how a corporate PPA can really help to finance and get projects built. In terms of the sectors signing corporate PPAs, it has been driven mostly by energy intensives. So ICT, these are your Amazon, Facebook, Google, and by heavy industry. So we've had a lot of PPAs signed, particularly for aluminium and metalworks. Alcoa, Norsk Hydro were the early movers, and they have a huge energy demand, so they tend to sign very big PPAs as well. But similarly to the countries, we've seen a huge diversification in the sectors which have been signing PPAs recently. And I looked at the details up to now, and heavy industry and ICT are basically neck and neck. Finally, I think it's worth considering the enablers of corporate PPAs. So clearly, a good pipeline of projects is really important. If you have bottlenecks because of permitting, for example, or grid connections, then there won't be the projects available for corporates to sign PPAs. In some countries in Europe, it hasn't been possible for generators to sign bilateral contracts with generators. So that needs to be possible. Another barrier we've seen is some countries have not supplied the guarantees of origin, or the IREX. These are key in order for corporates to prove that they are purchasing renewable electricity. And one of the key risks and barriers is credit risk, or the credit worthiness of the corporate. So is the bank confident that that corporate's going to be able to buy power at that price for the next 10 years? Well, not all the time, and there are ways you can mitigate this risk. For example, credit support systems or underwriting for developers. So that's all I'll say for now. Yeah, happy to take questions.
Before switching to the public Q&A, let's say, I have a few questions. Because we have been, as we have started the discussion 2.5 months ago, 2 months ago with you in Bilbao, we have been working to recommend or make a recommendation about a PPA mechanism in Turkey to the regulatory authority and to the Minister of Energy. There, the first question when we opened up the subject was like, hey, what is the duration? What is the minimum PPA duration? And the second concern and question came regarding the corporate risk. If the buyer falls into financial problems or goes bankrupt, and if, for example, the PPA is 15 years and the company, the consumer goes bankrupt in year 5, what happens to the power plant and to the generated electricity?
Yeah, these are good questions, and in fact, they're both related. So the longer the tenor, the more credit risk there is, the less likely that a bank is going to finance, is going to provide the debt to the wind farm. So the less likely the PPA is bankable.
Mm-hmm.
Tenors normally of a PPA will need to cover the length of the tenor of the debt which is provided. So normally it will need to cover 10 years, say, 15 years sometimes, on occasions a bit less. But yeah, I'd say you'd be looking at 10 years as a minimum. Credit risk and credit worthiness is one of the main barriers. And it is a challenge to know how to mitigate this. There are solutions out there available in some places. So the Norwegian government and the Spanish government have created a credit guarantee, particularly for energy intensive companies. So this guarantees the bank, well, both of these work in the same way. Either they guarantee the income to the bank or they guarantee the loan. So the income to the generator, or they guarantee the loan to the bank, but they work in the same way. They mitigate the credit risk. Often corporates will have to have a credit guarantee either from a parent company or from a bank, so a bank credit guarantee. Another way potentially of mitigating this risk is to have consortiums. So a consortia of smaller companies diversifies the credit risk. So it's unlikely that if you have 15 buyers in a consortium, that all 15 are going to go bankrupt in those times. And we're starting to see
insurance is within the mechanism itself. So there are 5 companies as consortium of buyers. If one steps out due to one reason, then the others continue. But I mean, the concern maybe is more related to the Turkish regulatory mechanism, because we do tenders for renewables, and they have especially with YEKAs, they have a mandatory sales period like government PPAs, but you don't have an option to exit. So if there's a 15-year PPA, corporate PPA with a company, and at year 6 the company goes bankrupt, and while the other power plant has been invested with a lower tender price and electricity sales price, and you have a market kind of market adjusted PPA, and after year 6 you don't have a consumer, so you have a power plant in hand, and what's going to be with that power plant? I mean, is the license owner or the investor will have the right to sell it to the market with the market price, or should there be another price? So this is the concern, mainly, because this is kind of a non-tender licensing mechanism, right, and it can kind of be abused.
Yeah, that I can see why it could be abused. Yeah, it sounds like a strange design to me. I think certainly the generators should be allowed to find ways of securing an off-taker by any means. If they're in they have a mandated contract and someone pulls out, then and surely either they should be supported by the government, or presumably if the buyer's pulling out, it's because prices are unfavorable. So I don't know if going to the market is the best thing, but that's certainly an interesting situation, and it's not one I've seen in the European market. But I'd be happy to have a chat with you separately, because I can't think how you would mitigate that.
this is one of the major concerns about before working on creation of a PPA market in Turkey. We have other mechanisms, direct or bilateral agreement markets, mechanisms, but I mean, a pure PPA needs to be well studied and to remove these concerns. And during also another question of mine, during your presentation, you mentioned that one of the zero-bit offshore projects in Germany, which I remember was tendered, I believe, 3 years ago, turned into a PPA. So normally, while it was tendered, it was supposed to sell to the grid, with zero. Since it's with zero, it was supposed to be zero, right? The electricity price or contribution fee or whatever. That needs to be zero.
Yeah, I mean the generator still needs to make money, so it can't sell for zero. The point is it doesn't get any support from the government. But as I said at the start, these generators need to have revenue stabilization. They need to understand what they're going to get in order to be able to pay their debts. So in the case where these developers are signing zero bids because they believe they can get the revenue certainty by signing corporate PPAs, that's the case at the moment. How many corporates, it could be that corporates continue to sign these large PPAs, but it might be that there is a reduced pool of corporates because of the credit worthiness problem. And it's worth noting that for a zero bid project, you can't have that in every market. The reason you can do it in Germany and the Netherlands is the government actually provides a lot of support for the grid connection, for the environmental impact assessments, for example, which allows developers to just develop the project. But if you go to the UK and try and sign a zero bid, it's not going to work, because you need to also come up with you need to do all the environmental impact assessments, you need to do all the pre-development, you need to do the grid connection. So it's market specific, and I think you need to have corporate PPAs to back up those projects.
Okay, so there needs to be lots of discussion to kind of adjust it to the Turkish market. So, of course, there are deviations between different market structures in Europe, but we have also our own way to license renewable projects and distributed generation projects, like own consumption projects. So it needs to be well studied before introduction of a local PPA contract mechanism in Turkey. So thank you for your comments and answers to my questions. Now I will switch to the Q&A session. We have many questions already arrived to my panel. Our organizers also, I have sent it to the Q&A chat screen, but let me go through those and ask you to more or less, all of you have certain questions. So let me switch to Till. He has a question from Sencer Özen from Izmir, a friend of ours. So he's asking about whether Nordex Group have its own ports to produce or manufacture equipment or assembly offshore wind turbines. But unfortunately, Nordex doesn't manufacture, as far as I know, any offshore turbines. But you can comment about your, it's market knowledge about how your competitors are doing it. Do they own their own ports, and do they manufacture their offshore turbines or offshore equipment at locations inland, or just at those locations where they have just near the port?
So I think in general, that's one of the major differences that we see between onshore and offshore. There's most of the, let's say, production facilities of onshore are traditional facilities in some areas that have been around for many years. and have worked with smaller turbine sizes in the past. And they're usually at least partially inland, even if it's only a kilometer or so from a port. But there's usually a connection via roads to ports from the production facilities. And I think when we look at onshore, and I can't really answer how the ownership structures are in terms of other OEMs on their offshore production locations. But I think it's fair to say that in general, offshore components, meaning blades and the nacelles, are usually, plus towers, of course, are usually produced really in the port, or let's say directly at the dock site, so that they don't have to use standard roads or normal roads, public roads, but instead can be loaded directly onto the installation ship to then be installed. So I think that's a major difference between the two sectors.
Yeah, so and the road infrastructure anyway needs to be well planned and sufficient for the transport of the offshore equipment anyway. Which, I mean, we have been working closely with the local industrial investors who are interested in offshore equipment investments. So there are expectations about establishment of an offshore facility just beside a local port in Western Turkey, and creating an industrial zone there. Just, I mean, kind of a clean industrial zone where onshore and offshore turbine equipment, towers, blades, and other equipment will be manufactured and easily transported through the port of the industrial zone. So there are studies on top. I mean, so thank you for your answer for my question there. Then the second question comes from one of our industrial friends again, Erinç Kısab, who's from an investment company, from one of the leading investors in Turkey. He's asking to Carolina and wondering about how grid connection decisions are taken for offshore plants, like how capacities are being allocated, like what preparatory studies are being done maybe by the grid operators so that they can allocate certain capacities to the offshore projects, and who is doing the investments, or who is taking over the investments of the grid connection, which links the offshore power plant to the mainland infrastructure.
Thank you for this question. Very important one. As mentioned at the beginning, we should not focus only on the offshore part, but this grid connection part is very important to follow in parallel to that what is going or what is happening offshore. So here there are different structures on the different markets. On some of the markets, the transmission is included into the developer scope. So developer is responsible for connecting offshore wind farm to the grid, onshore grid. There is, of course, a piece of this, let's say, the onshore upgrades, grid upgrades, which has to be considered. There are in the different markets done differently. Yeah, at the end of the day, it's more really like just the agreement or the, let's say, the market design, if this cost and who is going. So at the end, of course, it's going to be included in the LCOE, so-called, so the energy price, or some other services maybe done by TSO. More the owner of this task has to be defined at the beginning, and I think there are different concepts as said. Sometimes it's developer, sometimes it's the TSO. So a developer is the US, UK example. The TSO responsibility is in Germany, for example. And the last but not least, something which we are talking more and more about because of this upcoming portfolios in the different regions. So this kind of the coordinated transmission approach, if it would be for the North Sea, for the Baltic Sea, there are some in the United States too. So many different options, and you have to just really consider that. So what is your market specific design the best for? Yeah.
Mm-hmm. But whichever is the solution, it needs to be well studied ahead.
Yes, and there are
metrics.
exactly. So the grid studies should proceed with like kind of the offshore wind, that what I said, like where are the sites? There should be already a discussion. Okay, if we are seeing that there is a particular amount capacity coming by certain date, let's think about the yeah, of course, the grid development growth too.
Thank you very much for your answer. Now, another question came for Matthias. I mean, one of our colleagues, Soner Çelikdemir, is asking, he has two questions. One, about the future costs, which you have kind of elaborated. I mean, in fact, you have given some, but he's asking specifically about PM electrolyzers. So maybe you can give some an answer for that one. And he's also mentioning that there are studies in Turkey about hydrogen mixture, creation of a hydrogen natural gas mixture, and using it in the natural gas pipelines, and which I am sure is also being studied in Europe. So would also that be another area of use for hydrogen within the heating solution?
Okay, then I'll start with the first answer. Thank you for the good questions. I will not give an exact figure, but give you maybe something more interesting, which is two things to think of when you do hydrogen cost estimating. We see a lot of project developers from renewables come to us, and they are looking for a pre-feasibility and feasibility study with a cost accuracy similar to the renewable sector. Let's say you have already know quite early in the process, plus minus 20% the capex or something like that. Sometimes you get people that ask you for even higher figures or better figures. The issue with hydrogen is what we should not forget. It is rather similar to a power plant or a chemical plant in its nature. That means you need a lot more engineering, there's a lot more cost uncertainty at an early stage before you actually get to a good cost estimate. So my message would be, as a project developer for renewables, always have in mind that when you're developing a hydrogen project, you need considerably more engineering to get a good cost basis for your estimate, because unlike a wind turbine, there's less manufacturing in the workshop or the factory, and we are still at rather each project is different from the next one. So each installation is a lot different from the next one often. And the other thing is there's a lot of cost studies on what does PEM cost, in what size, what does alkaline cost. What's important is, if you see those costs, people often think of that's the total cost. But like for wind, you have civil, and that is the civil content is often a lot higher in hydrogen. You have not only the electrolysis, but as I've shown, you have a storage, you have compressors, you have gas heating and drying, you have piping, electrical. So it's actually a complex installation. So always ask yourself, if I get a cost figure, is it an entire plant, or is it just the electrolysis? Because this can make a huge difference. And finally, mixing of natural gas and hydrogen. So there's in Germany, we have already technical standards for this. We have allowed upper limits for hydrogen in the natural gas grid. So blending is an option, but when you blend, you always need to consider that you're taking hydrogen and putting it into the heat and power sector. And the question is, what is the revenue? So is it economically attractive to do that? So it's feasible in some parts, in some cities with most of the household connected to natural gas grids. It probably will have to be done to decarbonize, but it's probably not the best revenue stream that you can find. In Germany, there are cities like that. In the UK, it's I think 80% of households are connected to natural gas grid. That's why the UK is very focused on hydrogen in the gas grid. So yes, blending and ever higher capacity contents of hydrogen in the gas grid is something that's discussed. It's probably not the market segment that is going to be the first mover and the most attractive one.
Okay, thank you for your collaborations. Two short questions to the. I mean, one is to Vasiliki and the other one is for Guy. To Vasiliki first, about the regulatory framework of the battery storage and hybrid power plants. How is it being developed? I mean, as representatives of in Europe, also both of you, you are aware of the development risks and permitting risks more than everybody else in Europe. So can you elaborate about the permitting procedures of the hybrid and storage facilities?
Yes, thank you for the question. So as I mentioned before, most of the countries in Europe, they have not established this kind of power plants or even storage in the regulatory framework. So this is a major barrier, and it is very important for countries to do that, to include the definitions and to create a framework for this kind of assets. Then, even in countries where assets have been established, often the rules for grid connection, so grid access, that is grid permits, that is part of the permitting process, are not clear. They are not customized to this type of projects, which has, as a result, these projects been treated on a case-per-case basis. So there is no standardized process, and of course this adds to the complexity and makes it less inviting for developers to think of developing this kind of assets. Specifically for the hybrid power plants, so power plants that combine different generation technologies with or without storage. Something that, based on our discussions we have had with developers of projects, of renewable energy projects, something that is extremely important is that the transmission system operator or the national regulatory authority allows in its framework the developers to install more total capacity than the one that has been contracted with the grid. Because this is the only way to take advantage of the synergy, the potential synergy, the complementarity of the wind and solar resource, for instance, in the locations that, of course, there is this complementarity. So it's very important that in some countries it is the case. So it's possible to install more capacity no matter if you inject less. So if your grid connection is contract is less than what you have installed, but in others you cannot, and this actually in a way kills the business case of hybrid power plants.
Thank you for the answer. And we started the Q&A with Guy, and then hopefully we will finalize it with Guy again. I mean, my question in fact is whether corporate PPAs would eliminate completely the government subsidies for renewables. So how do you see that in the future?
Yeah, thanks for that question. I mean, a short answer is I think no. I don't think there's enough corporates able to purchase the amount of volumes that are required in order to meet the targets. There are some markets in which corporate PPAs are the only revenue stabilization tool out there. So if you look at the Sweden and Finland, for example, the government doesn't actually provide support. So corporate PPAs do make up, the difference there, but you need to have certain specific conditions in those countries. They have good permitting. So the permitting allows developers to use the latest technologies. They have very good conditions for wind, and they also have a liquid balancing market, which allows traders to make sure that they can supply the needs to the corporate consumer. So in some specific situations, corporate PPAs might replace government support. But in general, I think we're going to need a combination of both government support, corporate PPAs, merchant projects, and any other type you can think of in order for us to get to the huge targets that we need to meet in order to hit those climate targets.
Okay. Thanks for this summary. So they will coexist, hopefully, in the future.
I think
maybe
so.
In some markets, may not be in some markets. I mean, I apologize from all of you and from our listeners because we have kind of like passed our timing 11 minutes. But I didn't want to interrupt any of you because it was such an interesting subject with your personal subjects. And we have seen lots of questions coming. There are many other questions already there. So we all expect you, hopefully, as I said at the beginning, later this year to Izmir, Turkey, so that all of our listeners or audience can ask you most of those questions directly. So thank you all. And after all this discussion, thank you to Wind Europe to helping us organizing this event and putting us together with Guy and the other friends, us and Vasiliki, and to Figner and to Nordex also great thanks to all of them, because without them we couldn't have such a beautiful discussion together. So if you don't have any other words, I will close the discussion.
Thank you very much.
Thank you for having us.
Thank you very much. Have a good day.
You're welcome. You're welcome. Thank you very much. So I will switch to Turkish. Herkese güzel bir.
Well then, this brings us to the end of the session, and I'd like to thank everyone for their contribution. Have a nice day, and I do apologize for exceeding the time limit. Hopefully it's been useful for all participants. Thank you.